Good evening, good evening, good evening, everybody. Welcome, welcome. It is Wednesday evening. It is 9 o'clock, and it is time for some physics. This evening, we're going to take a look at some core skills in physics. We're going to take a look at rearranging equations, be it from analysing graphs like we did 2 weeks ago with y equals mx plus c to all the myriad equations that you're going to end up learning throughout GCSE physics. You need to be able to manipulate these equations, you need to be able to move them around, and you need to be able to get the right answer from them. So let's get started with let's start with a basic equation at the start. Let's try something like 2x plus 9 equals 17. Okay. So this is actually an equation that's solvable in that it's only got one unknown. But I'm not really interested in the solving bit. Before I get on to that, I want to actually talk about what this means and how it works. Okay, so we have 2x plus 9 equals 17. So the key thing I want to talk about here, first of all, is what the equals sign means. That if we imagine an equation to be something similar to a set of scales, what the equal sign does is it separates one side of the scales from the other side of the scales. Okay, so this is an old kind of style top pan balance that we've got here. All right, and what we've got on the left hand side is a little block. It might need to be a little bit smaller than that. There we go. And we're calling that block 2x. Okay, so we've got a block of 2x here. Grab those, stick them together. Grab those and stick them together. So we've got a block of 2x. We set that in the scale. Okay, and we've got a block of and 9. So we've got a block of 9 as well. I don't know what 9 is. There's no units or anything. We're just 9. So we've got a block of 9. And stick that in there. Now, I don't know if 2x is bigger than 9 or not. I can probably work that out later on. We'll make them roughly the same size to get with. Okay, so that's what we've got on one side of the equation. And we're saying that that is equal to 17. So on the other side of my equation, we're going to copy that if I can. And change that to 17. On the other side of the equation, we've got 17. Okay, and what our equation is saying is equal just means is. Right? Kind of fancy maths terms, but what we're saying is 2x and 9 is 17. So we've got a perfectly balanced system here. Now, the thing that I want to talk about is the way I've split this up. I don't have a single block of 2x and 9. I have a block of 2x and I have a block of 9. And why have I chosen to write it like that? Then I could have had 2 blocks of x, couldn't I? And then another block of 9. And the reason I've chosen to write it like that is because of something in maths called terms, right? That we group terms together. So what I have here is a term is essentially, and we'll put this down here, a term is a number. Okay, nice and simple. It's some form of number. We may know the number, we may not know the number. In the case of x, we don't know what it is. In the case of 9, we do. Okay, but more importantly, terms are separated by either pluses, minuses, or equals signs. Equalses, if that's a thing. Okay, so anything that isn't separated by a plus, a minus, or an equal is the same term. Okay, hello Vladimir Lenin, just saying the hello in chat there. Okay, so when we multiply things, when we divide things, when we put them all together, we are not separating them out, and therefore they are the same term. All right, so this 2x is a term. This 9 is a separate term, and it's a plus 9. And this 17 is a term over here. So this has 3 terms. And you've heard your maths teacher saying, move this term here, or write these terms down, or manipulate these terms in some way. That's what we mean when we talk about a term. A term, essentially, it's a number or a variable, and they're things that are stuck together by either multiplication or division. Okay, we can square them because that's just multiplication. We can do all sorts of things. We can square root them. That's still like some form of multiplication system. But pluses, minuses, or equals makes them separate from each other. Okay. Now, what we want to do is, if we want to solve what x is, then what we're going to have to do is we're going to have to isolate x, and it is as mean as it sounds. Okay? That x here can have no friends. x must be made b by itself on one side of the equation, whilst everything else is over on the other side being dealt with as its own thing. Alright, so it's like mathematical bullying. So what do? Well, we work our way from as far away from x inwards. And that's the kind of core of this. So if I was trying to figure out what x is here, well, first of all, I'd probably get rid of the 9. I just dump that off. Okay, so I'm left with 2x. But the instant I do that, I've like taken a pile of weight out. This side's then heavier, isn't it? Because these things are supposed to be equal. So the 17 side goes down, the 2x side goes up, and this is no longer true. It's not true to say that 2x is 17. Okay, which is what we've essentially done if we've taken the 9 off that. Sorry, 2x is 17. And that's not true. That's not true. What we would have to do is, if we were taking away 9 here, we would have to somehow magically take 9 out of this 17 box and float it off as well. Well, we can do that. Mathematically, that's pretty straightforward to do. Like 17 with 9 removed from it becomes 8. Yeah? Okay, so now we're in business. We've got 2x is equal to 8, and that is true. So let's come over here. 2x is 8. And this isn't the way you would lay it out. Obviously, you wouldn't draw pictures in an exam, but this is to visualize it before we get on with it. Okay? So we've got 2x equals 8. We don't want 2x. We want just 1x. Okay, so what I really want to do is I want to cut this in half. And I want to get rid of half of this. Okay, so I just want to shear half of that off. Okay, so let's mask that over with a little red box. I want to get rid of half of that. So I don't have 2x anymore, I would then just have x. But again, if I cut off half of this, then this side becomes lighter, this side hasn't changed in weight, so we'd end up with it not being balanced anymore, and it wouldn't be true that x was equal to 8. What I would have to do is I would have to cut the weight on the other side in half as well. Okay? And that would make that equal to 4, because we know how to half 8. It's straightforward enough. And that gives me my final answer. I've got x equals 4. X is by itself, it's been isolated, everything else has been dealt with, and in this situation we can solve it. We end up with the actual answer that x is 4. Okay? Now, the question is, why did we do that? Why did we take away 9, and why did we do all that type of stuff? So let's go back to our original kind of premise, which is that we have this, we have 2x plus 9 is equal to 17. But we're going to do it a little bit more clinically over here. So with 2x plus 9 equals 17. I want to take a look at layout here. Right, we want to talk about inverse operations. What I want to start off doing is I want to get rid of the 9. Right. I want to get rid of the 9 because it has the least to do with x. I could get rid of the 2 here. I could start by doing that. But that's quite difficult to do because I've got another term here that I would have to deal with. And we will try and take a look at that later on because sometimes it's useful. Right. Thanks, Andy. I appreciate that. So what we're going to do is we're going to get rid of this 9 first. And we need to understand inverse operations in order to do that. In maths, we have operations and their inverse. That sounds really technical, but it's not. Okay, so this is my operation, and this is my inverse. INV for inverse. Oh, clicked the wrong place. Well, that looks great, doesn't it? Better. Not better, but it'll do. Okay, so if my operation is plus, then the inverse operation to plus is minus, right? This is high level stuff here. If my operation is negative, my inverse of that, the exact opposite, the thing that undoes negative, is plus. If my operation is multiply, my inverse operation is divide, and you could use an actual dividing sign. And if my operation is divide, my inverse operation is multiply. Thank you, Trader Will. Can I donate? No, there's no need to donate. I'm a teacher. I get paid an absolute fortune, isn't that right? I'm one of the best paid professionals there ever was. And then the Conservative government happened. Anyway, moving on. If my operation, however, was something a little bit more interesting, like say it was something that's called x squared, okay, well then the inverse of that, how do you get back from squaring something, would be that you would have to square root it. So it would be to take the square root of the thing, which is really hard to draw on this, but it doesn't have an equation editor, but we'll do it like that. Yeah, that's pretty good. Okay, so are we happy enough with that? Yes, Patty, what method do we do? It sounds really complicated. Can you not just minus 9 on both sides? Yes, I want to explain why we're doing minus 9 on both sides. Why does it feel right to take away 9 on both sides? Why don't you divide by 2 to start with, is what we're trying to get through here. So these are their operations and these are their inverses. And we want to apply that to our situation here. Okay, so I'm just going to get rid of this little diagram here. I think it's served its purpose. So what we've got, we want to start by getting rid of the thing that has least to do with x, because the game is to isolate x by itself. So we work our way outwards and inwards. So what we've got is we've got a plus 9. The exact inverse operation of plus 9 is negative 9. Okay, because the inverse of plus is minus, so plus 9 inverse minus 9. But because we've taken 9 away from one side of our balanced equation, we must take 9 from the other side of the equation. And this is how I would have it laid out, that my first line is my actual setup. Then my next under that I will have minus 9 and minus 9 on both sides of the equation. And then I will rewrite what that means. So if I have 2x plus 9 minus 9, that simply gives me 2x. That's the purpose. The purpose was to get rid of that 9 equals 17 minus 9 is 8. So just exactly the same as we did earlier. Okay, this seems a bit mundane for an equation this simple, but we'll quickly ramp up to more difficult things. Now 2x, again we need to understand what our algebra is saying. What that says is 2 times x. I've put a little star there because I've got a couple of x's going on here. I don't want to write 2xx. So that star means multiply. That means 2 times x. But we should know that multiplication can take place in any way we want to do it. That 2 times x is exactly the same as x times 2. And it's this that we're trying to get rid of. We just want x. We don't want x times. We don't want times x. We just want x. So we need to get rid of this times 2 situation. Now, you probably understand that already, so we don't bother writing that down. We just leave it as 2x. So the inverse operation of multiplying is that we're going to divide. So I want to divide by 2. So I want to divide this side by 2. But because I've divided that side by 2, I have to divide this side by 2 also. Alright? The result then is 2x divided by 2 is x, which we fully expect because that was the purpose. It was to get rid of that 2, equals 8 divided by 2 is 4. And that's my final answer. And you'll see that there's 1, 2, 3 lines of working out, but there are 2 little interim lines of explaining what it is that you're doing. I could just use, Jeffrey, I could use the open brackets, closed brackets for x, but that would take a little bit of time and it might look weird in my font. Okay, I might just stop using x. That'll be a better idea. Okay, are we happy here that this is kind of simple? But let's move up to something a little bit more complicated. Let's work up with something that actually has 2 variables in it. Okay, so let's start with 3y equals 2j minus 7. All right, this is a little bit more interesting on this one. And let's say we want to make j the subject. Okay, now when you say you're going to make j the subject of an equation, what you mean is you're going to have it isolated by itself as 1j, just j, on one side of the equation. It doesn't matter which side. That's really important. You don't have to have it on the left side or the right side. Okay, it can be either side, just by itself. So let's get started with our process as we started with before. So where do we want to get going? We want to get going with this minus 7. Okay. The reason we're going for the minus 7, it has the least to do with j, and we're trying to isolate j. Okay. We're trying to get the peripheral hangers-on bits of j. So how do we get rid of a minus 7? We do the exact inverse. So that's going to be plus 7. Because we've got a plus 7 on one side, we must do a plus 7 on the other side. Okay? That then leads us to 3y plus 7 is equal to 2j. And it's this next bit that I really want to focus in on. I really want to focus in on this, because there's a couple of ways now to approach this. We want a single j. This is 2 times j, or put better, j times 2. So we want to divide both sides by 2. So we're going to divide that by 2, and we're going to divide that by 2. Now, the most common mistake that we see as examiners in this type of situation is that you get 1.5y plus 7 equals j. And that's wrong. Okay, you probably feel that that's wrong already, but we need to understand why that's wrong. All right. First of all, notice what I said before. I said we wanted to divide both sides by 2. Okay, so if I'm dividing this side of the equation by 2, I must divide this entire side of the equation by 2. Okay, which means that it should be 3y plus 7, and that whole side gets divided by 2. So that ends up as a fraction, because fractions are a really good way of writing divide by. Divided by 2. Okay, because it's the whole side that gets done, equals j. And that's a fine way to leave it. In fact, I would be very tempted to leave it at that. But because we were talking about terms, let's do slightly more in-depth treatment of this. Okay, what we can do next is we can say when we're dividing sides, what we mean is that every single individual term gets divided. Now, this is true for division and multiplication only. Right? So when you're multiplying or dividing on either side of the equation, if you're dividing the whole side, you divide each individual term one at a time, at a time, at a time. Okay? Adding and subtracting, you just stick them on extra. It's not a big deal. Okay? And the reason being that, let's take ourselves back to our little boxes. I have a box of 3y, I have a box of 7, okay, because they're separate terms, and I have a box of 2j on the other side here. So I'm trying to visualize this. So this is my 3y box, and this is my 7 box, and this is my 2j box. Right. Now, if I'm dividing them by 2, what I'm essentially saying is I'm going to cut them in half. Yep, so I'm going to cut them in half. So let's do that. Let's get our red box back out and slice them in half. Now, if I cut them in half, I have to cut both sides in half, so I end up with both sets being cut. Notice the 3y gets cut in half along with the 7 in order to make sure that the 2j is exactly the same. Okay, can we see that if these two things were on a balance scale, that this would be leveled out? I hope that makes sense. So visually speaking, we're going to cut that in half. Mathematically speaking, what we do then is we do 3y plus 7 equals 2j. Dividing both sides by 2, I divide 3y by 2 to get myself 1.5y. I divide the 7 by 2 because it's a separate term, gets me 7 over 2, which is 3.5, equals 2j divided by 2 is just j. Okay, so notice that at the start of this equation, I had 1, 2, 3 terms, and I divided 1 term, 2 terms, 3 terms, because I was dividing both sides of the equation. So if you're insistent on getting it kind of as accurate as possible, if that 7 annoyed you or this whole fraction annoyed you, this is a perfectly fine way of writing it. I happen to think that this way is a little bit more elegant. This way is a little bit clumsy looking, but they're both mathematically correct, both acceptable as exam answers. They're 100%. All right. So let's up the difficulty just a little bit further. Let's try and introduce some other terms in here. So let's try something like aj squared. So we've got 2 variables and a squared system going in here. Plus np, no problems at all, equals q. Right, so in this one we've got no numbers at all going on whatsoever, and we're going to make j the subject. Make j the subject of this. Alright, so let's see what we've got. Well, first of all, the game is get j isolated by itself on one side of the equation. So this plus np has to be the first thing to go. Now plus NP, you treat it just like a number. It's just like 6. And if you're stuck, have a think about what would I do if I knew what these were. Like if this was plus 6, what would I do? I'd subtract 6. It's plus NP. That's just a number. So I'm just going to subtract NP. So that's going to be take away NP from that side. So I'm going to take away NP from that side. Okay, it's not a multiplication, it's not a division. It therefore doesn't need to be something that we do to all the terms. So what I end up with? I end up with AJ squared is equal to Q take away NP. Brilliant. Okay, so let's work my way in. What comes next? We want to work our way towards J, getting rid of all the things progressively getting closer and closer and closer to J. So I'm getting rid of this A. And a lot of people have a little bit of difficulty here going, oh, it's an A, what's that about? Well, if it was a 4, what would you do? You'd divide by 4. This is an A, you divide by A. Simple as that. Okay, you treat it just like a number. Since I divided that side by A, I divide this side by A, and this is a division, so therefore all the terms need to get treated the same. They all need to get done. So AJ squared divided by A just gives me J squared equals, now we divide all of our terms by A. So there's two possible ways of writing this. Either I write, as I would prefer, Q take away NP, and then I do myself a nice big fraction like this and say that that's all over A. Right. Or, and I'll write this in red I suppose, or we can write it as, this takes a while because fractions are hard in this, we can write it as Q over A. Okay, do the first term first, so we divide the first term Q, and then we'll have that as minus, and then the second term gets divided by A as well, NP over A. Now hopefully at this stage you'll have done enough fraction work to understand common denominators, and you'll see that these two things are true. That if I was to give you Q over A minus NP over A, you'd almost certainly go, oh well, there's a common denominator of A, and write it like this. So that's why I prefer this setup to this one, because you'll almost certainly end up back here once you simplify it. Alright, so this leaves us finally, so we're going to work from this one. The or is fine, we'll just pop that out there, we'll come back to it in a minute. Okay, now, J squared, we need the inverse of J squared. So what's the inverse of the squaring something? I need to get rid of this squared, so I'm going to square root it. Okay. Now don't fall into the mental trap of saying I'm going to square root J squared. Okay. Don't fall into that trap. What you want to think is I'm going to square root this side of the equation. And therefore you fall into fewer traps by then saying I'm going to square root the other side of the equation as well. The square root of J squared is simply J. I'm going to copy and paste this down because this is going to take an age to sort out again, so we'll just copy and paste that down there. Is equal to, I need to square root the whole of that side of the equation, so that is the square root of all of that. Alright, now that makes it a little bit, again it's just a little bit easier to write than taking the square root of all of this side, which does just end up having to be under the whole thing. Now notice I've made a really big deal about making my square root sign very, very large, because you don't want to get into the situation where you have this. Okay? Because what are you trying to tell me? Are you trying to tell me that you're square rooting Q minus NP over A? Or are you trying to tell me that you're just square rooting this top line here and then dividing the whole thing by A afterwards? That's not entirely clear. And if it's not clear, it doesn't get a mark. Okay, it has to be clear on this one. So square root the whole side of the equation gets you this. And realistically, that's about as difficult as it's going to get for you. But let's go for one last example with maximum insanity, if we possibly can. So let's try AB squared, and we'll have a fraction in it to start with. I think that's probably a good idea, over r cubed. I'll put that in as a fraction. And then to that, we're going to add 6. So we've got a number in here. Then we're going to minus p, and we're going to have that equal v. Okay. And probably the most difficult thing you can do here, is make r cubed the subject. That's almost a little bit too complicated. So let's go for b squared. B squared. We want to make b the subject. Okay, for those of you who want extra credit in this one, have a crack at r cubed. Pop in the comments below what you end up getting for r cubed, or for r being the subject. It'd be interesting to see how you manage with that. My hint is use brackets. Brackets are important. Okay, and we might come back to that for the last little kind of couple of seconds. So if this is easy for you, run off and try and make r cubed the subject, or r the subject here. We're going to make b the subject on this one. Okay, so the principle is exactly the same. Let's start with the outline stuff here. So we've got this and we've got this that don't really have anything to do with b squared. So we're going to ping those off first if we possibly can. All right, and we're going to do it one step at a time. Though we probably could do them put a couple of steps together once we get good. I wouldn't. And I'm quite happy writing stuff. It makes my page look great. Maths looks awesome on a page. So leave it alone. Leave it alone. Make it look like you know what you're doing. Make pretty mathematics. Alright, so over r cubed. The only thing that's going to be slightly annoying is continually drawing this fraction out, but I'm sure we can find a way around that by copying and pasting. Okay, plus 6 equals v plus p. Okay, we didn't have to do everything to the same to each term because we had a plus situation going on here. Now I want to get rid of this plus 6, so we want to do the inverse operation of plus 6, which is minus 6. We have to do that to both sides, and this should be starting to grind its way into your psyche now that this idea is it's not just take away 6, it's take away 6 from both sides, from both sides, from both sides. Make that thought happen in your head. Okay, that leaves me with just my fraction part, which is that. Gives me ab squared over r cubed equals, we want black for this one, equals v plus p take 6, which is the same as v take 6 plus p. You could do that as well. If you'd taken away the 6 first, it makes no difference. Alright, so let's work our way in here. We've got ab squared over r cubed. Now, personal hatred for fractions. When you're trying to work with stuff, get rid of fractions if you possibly can. So this one, we're now going to get rid of this r cubed. So this is divide by r cubed. So we're going to multiply by r cubed. So on the other side, we're going to multiply by r cubed as well, times r cubed. Alright. Now, two ways of writing this one. We end up with ab squared. That's the straightforward bit here. That's why we did it. We did it to get rid of that r cubed. Equals. Again, the elegant way of writing this is kind of like this, that we have v plus p take away 6 all multiplied by r cubed. Okay, and we use brackets for that purpose. But if we're not completely happy with that, we can just go or, and there's going to be lots of r's appearing here. We have to do each term individually, and we've got 3 terms to do. We've got a term here, a few too many highlights there, a term here, and a term here that needs taken care of. Okay, so 3 terms to do, so 3 sets of r cubed. So or we get v times r cubed plus, bring that back down, plus p times r cubed minus 6 times r cubed. Okay, these two things are exactly the same. Just this one looks a little bit more elegant because we're never actually going to bother with finding the r cubed. We just want to get b by itself. So we're going to continue working on this one. In fact, we'll work on both of them simultaneously so that we can see how they end up looking at the end. Okay, so we're working our way towards making b the subject, so we now need to get rid of the last thing that isn't b here, and that's a divide by a. Okay, and we need to divide both sides by a. Right, so in this situation, that becomes relatively straightforward, so we'll copy and paste that down to our next line. I know that feels like cheating because you have to write it. But dividing by a then gives us all of that over a. Okay, and this is keeping it nice and neat. The slightly less neat version, but no less correct version, has us with all of this over A. Okay, all over A. And to be technical, and dear God help you and whoever's marking your paper, if you go for the extreme end of things, which is that because we're dividing by A, we should divide every single term by A, that we would actually end up with each individual term divided by A. So we would have VR cubed over A, PR cubed over A, minus 6R cubed over A. Right. If you do that, again, it's not wrong. It's unpleasant. It's not pretty. Okay, and if you were going to have to do what's the purpose of doing this? You're rearranging to get B the subject, so you can probably solve B later on. You want to make that as pain-free a process as possible to put into your calculator. Like this is just riddled with the possibility of errors. But finally, we are almost there, so let's get our red color because we're doing our calculations red. To get from B squared to B, we need to square root this side of the equation, which means we need to square root this side of the equation as well. Which gives us, taking all of this and pasting it down to here, we have our final answer to this, our final rearrangement, is that we have B equals the square root of this entire side. Or B equals the square root of this entire side. Or B equals the square root of all of this. Okay, notice, doesn't matter. Once we square root it, we must square root the whole side. All right, many thanks for tuning in tonight. We're 2 minutes over time, but I hope this gives you a little bit of a better idea as to how to rearrange equations in all the various different bits and bobs. Practice for this in terms of identifying terms is, would you go and down into the description below, there's a little link to a PDF, so would you grab that and have a go at it. Thank you so much for your attention. All that remains for me to say is, don't forget, physics rocks. It's true.